Welcome back. And we're continuing to talk about the chemistry of solutions. In a previous video, we talked about the solubility of solids in water, and we said, generally speaking, as water temperature increases, the solubility of those solids increases. When temperature decreases, their solubility decreases. Well, today I want to look at this graph. And on this graph, I have 5 gases. This is a gas, this is a gas, these are all gases, kiddos. And I know this is in grayscale. It doesn't need to really be in color for my purposes today. The point I'm trying to make with this graph is no matter what gas we're dealing with, take a look at their solubility and how it changes as the temperature increases. Gases do not dissolve as well when I increase the temperature of their solvent, which in this case is water. Now we can look at that backwards, of course, and say, well, what if we cool it down? Well, if you cool it down, of course, the solubility of gases increase with a colder temperature. That's the opposite of solids, kiddos. So what happens to the solubility of gases here, kiddos, when temperature is increased? Yeah, gas solubility decreases with an increase in temperature. I mean, you've all seen this before. Imagine you get a nice glass and you fill it full of nice cold water from your refrigerator. There's no ice in there, it's just nice cold water. And you sit it out on your countertop. And you come back later and it's much warmer now because it's no longer sitting in the refrigerator. Do you notice on the inside of the glass there are tiny water bubbles that have formed? That is gas that's dissolved in water when it's cold coming out of solution as it warms up, because the solubility of gases decrease when the temperature increases. So that's bubbles of air, oxygen and nitrogen, coming out of solution in that cold glass of water as it warms up. So let's state a little profundity here, kiddos, related to our discussion on solubility of solids and gases. So the solubility of solids generally does what with an increase in temperature? Very good. The solubility of solids generally increases. They dissolve better with an increase in temperature. How about the solubility of gases? What happens to their solubility when there's an increase in temperature? Yeah, we've just been talking about, look at the graph above. As the solvent temperature increases, the solubility of gases decreases with an increase in temperature. Here, let me give you a good example. Where do fish get their oxygen from? Let's say you go to the store and you come home with a goldfish, and you put some nice fresh water in that bowl. Maybe you put a little treasure chest on the bottom so it looks like it's, a cool little fish tank. Have some gravel down there. And here is your fish tank, or your fish, your goldfish, all happy as can be, swimming around in its tank. Where does it get its oxygen from? It needs oxygen. Yeah, that's right. There's oxygen that's dissolved in the water. So there's dissolved oxygen in that water. Why do goldfish die when their water is not changed regularly? Yeah, you probably also have seen this. Maybe you don't change the water regularly in that little bowl, and you still have your gravel, still have your treasure chest here with treasure in it, but when you come back a couple of days later because you've neglected your fish tank, your fish is now upside down, floating on the top. And what did it die from? It died from the lack of oxygen, didn't it? It used up all the oxygen that was dissolved in the water. So why do goldfish die when their water is not changed regularly? Because they run out of dissolved oxygen. Fish need oxygen dissolved in their water in order to survive. Now, of course, to prevent this, some people will buy like an air stone or a bubbler, you might call it. Well, there's a tiny little compressor here that pumps air into the fish tank, and bubbles that air in there, and more oxygen can dissolve in the water. When you do that, and your fish can live lots and lots longer. The point is, fish need oxygen to survive. Some fish need more oxygen than others. For instance, think of trout. Trout are a very active fish. They expend lots and lots of energy. Why do you think trout go to deeper water in the summertime? Yeah, at the surface of the lake, the water's probably much warmer, isn't it? But as you go deeper and deeper in the lake, isn't the water cooler? So colder water has more dissolved oxygen, doesn't it? Remember, gases dissolve better when the solvent is cooler. So colder water has more dissolved oxygen in it, and so the trout are more comfortable there. Of course, they'll rise to the surface and they'll eat, but then they'll go back down to where it's colder and there's more dissolved oxygen. They have a higher oxygen requirement than many other types of fish. Why do we keep our open soda pop bottles in the refrigerator? Well, now we're not talking about dissolved oxygen, are we? We're talking about carbonation, dissolved carbon dioxide. So, what happens when we keep them in the refrigerator? Well, colder temperatures equals a higher amount of dissolved carbon dioxide. In other words, we maintain the fizz, right? The CO2 stays dissolved better when my soda pop is cold. If I take that open bottle out and just leave it on my countertop, yeah, you're right, warm soda pop doesn't taste very good. But at the same time, doesn't it get flat faster? Because as it warms up, gases don't dissolve as well in a warmer solvent. Okay? So this portion of our notes here is really what I wanted to hit on today. It actually wraps up 2 videos. Remember, the solubility of solids generally increases when temperatures increased. However, the solubility of gases decreases with an increase in temperature. They're opposite each other. All right, we'll talk more about solution and solution chemistry in the next video, where we discuss a pretty important concept in chemistry called molarity. So I'll talk to you soon. Bye-bye.